Here's something really cool. Freezing point. Oh, I can't spell today. Freezing. Oh, just today? Yeah, that's right. Freezing point depression. And boiling point increase. I know, I'm having trouble today, aren't I? Okay. All right, I need to slow down a little bit. They both use the same basic equation.
Triangle T equals blue
Okay? They both use the same basic equation. Okay? The difference is here and here. All right? So for freezing point depression, this equation becomes delta T for freezing point, equals I times K sub F, subscript F, times M for molality. And boiling point is delta T sub B equals I times K sub F times molality, or mole concentration.
Is that molality?
No, not under. It's molality. M-O-L-A-L. Molal concentration. Okay? So it's moles of solute, kilograms of solvent. Okay? So let's define some of the terms then. Let's make sure we know what they mean. Okay?
So it's like a formula for it or something?
That's right. Okay? So delta T just means the change in temperature. The change in temperature. And you could find the change in temperature by subtracting the beginning temperature from the ending temperature, or the ending temperature from the beginning temperature. But if you want to know what direction the temperature is changing in, you always start with the final temperature minus the initial temperature. So with delta T then is going to be the final temperature, temperature final, or minus temperature initial. Okay, final meaning ending and initial being beginning. Okay? Okay, so final temperature then is always going to be the temperature of the freezing or boiling temperature of the solution and the initial temperature is always going to be the freezing or boiling temperature of the pure solvent. Move it up. Oh, down where? That? Oh. Now everybody can't see what's down there. Barely. Okay. We got that?
Yep.
All right. No? Yes? Oh, Morgan's still working? Okay.
Yeah, just
You know-
go on
You weren't doing your math homework today, were you?
there.
Okay.
Surprisingly.
Yeah, I know. Okay. All right. I was listening today to something on the way into school about how they business and industries are really looking for people that are good at math. I mean, they really are. It's a big thing.
It's called that money.
Yeah. But you know what? You know what the highest paying job is coming right out of college?
Accountant.
Chemical engineering.
India.
All right. Anyway, we got that.
Yeah.
All right. I is something that's called the Van't Hoff. That's a lowercase v, but a capital F. Van't Hoff factor. Okay.
Wasn't that like property or something?
It is, well, actually it is a property, but in this class, we're only going to deal with that part of the Van't Hoff factor that deals with the colligative properties. Okay? So we're going to simplify the definition by sticking with just colligative properties for the Van't Hoff factor. Okay? All right. Because the Van't Hoff factor can take into account particle interactions. Remember, colligative properties assume there aren't any. Okay? So we're only going to use Van't Hoff factor for a much simpler way, in a much simpler way. Okay? So the Van't Hoff factor then is the number of particles a formula I can't speak. Golly, formula. I know, breaks into the number of particles a formula unit breaks into in solution. Okay? The number of particles a formula unit breaks into in solution. All right. So, it has to break up. Remember when we were writing complete and net ionic equations? We had to break up ionic and acidic formulas. Okay, when we first started writing formulas, back in Unit 3, we would take ionic symbols or formula symbols like calcium and chlorine. We'd go to the periodic table with oxidation numbers and find that calcium had a 2+ charge and chlorine has a 1- charge. And we do this kind of math, 2+, 1-. We'd find the coefficients that fit in front of that. So we have an overall 0 charge when we're done. And so then 1 goes here and a 2 goes here. Remember all that? Okay. So we have 1 of these and 2 of those. And we put them together. Then we get CaCl2. This is unbonded. And that coefficient 2 becomes a subscript when they're bonded. Okay? And then when we wrote complete and net ionic equations, we took this formula like this and we split it up into separate ions. Calcium, 2+, and 2 chlorides. Okay? 1-. Remember that? All right. This is what we have to do to find the Van't Hoff factor. We have to split it up. Just like when we wrote the complete and net ionic equations. The Van't Hoff factor for calcium chloride. Calcium chloride is soluble. If you go to your solubility rules, you'll find that chlorides are soluble. So in water, they break up. They are soluble. Okay? And any ionic or acidic compound that is soluble breaks up into separate ions. But it has to be ionic or acidic. It can't be covalent. And so it breaks up. Well, the number of particles the formula breaks up to into solution is the Van't Hoff factor. So for calcium chloride, I equals 3. 1 particle here and 2 particles there. Does that make sense? Zach, you understand? Katie? Zach, sit up. Katie, sit up. Thank you. All right. All right. So let's theoretically dissolve salt, table salt. You figure out how it breaks up and tell me what the I or Van't Hoff factor is.
Is it already balanced?
No, I haven't balanced this right here. This is balanced. I haven't done anything with this.
That's what I was
Now you're going to figure out what goes over here, break it up, count the ions, and tell me what I is. And don't say it out loud. Just write it down on your paper. Practice. Practice now. Perfect results on the test. Perfect practice makes perfect results. Yeah, I've started out like it's a solid, like table salt that's solid crystal, and I've written water on the top to show that I'm going to put it in water and dissolve it.
Hey, Mr. Taylor,
Yes.
how long you been doing this? How many years?
About 15 years.
What'd you do for that?
I did a lot of different things for that.
What you do?
I was not a
You was in
meteorologist.
the band, wasn't you?
In high school, I was in the band.
What was your name, Mr. Taylor?
And he quit football to be in the band.
Yeah, my coach was not happy about it either.
Did you hear what happened?
Oh, we didn't need you. Nah, I'm messing with you. What position you played, Mr. Taylor?
Oh, let's see. I played a lot of different positions. Okay, I won't.
Oh, what did you play, Mr. Taylor?
I can't say now.
I said linebacker.
He said I couldn't say linebacker.
You can say all the other positions, like
Oh,
20 others.
all right. Well, let's see. I played guard.
Okay.
I played defensive tackle. I played something I can't say.
Love that.
Nose guard.
I played tight end.
Outside of this.
Oh, I know what he can't say.
Linebacker.
Oh, no, no, right. Oh, I'm tripping. That's my
All right.
Hey, see, it's creepy over there.
Okay, guys. What's I for this? 2. It breaks up into 1 sodium and 1 chloride ion. Okay? Okay. Okay, figure out what that's going to be.
You were big, but you played.
Hmm?
You played O-line, so you were big, but.
No, I wasn't that big, but it was just, back then, you didn't have to be that big and you could still play.
Where you went to?
It's a little town in South Georgia,
Called.
Bainbridge.
Never heard it.
Yeah,
It's high school?
a town and a high school, yes.
How many
All right,
people-
do this work, please. Huh?
how many
Let's
people-
figure this out, please. Let's figure this out, please.
how many grades go get full up 5 grades for the semester? Like, so like big grades.
Well, your final grade, I think it's 9 years. I don't know how to do it.
You gotta get an exam, so.
You gotta break it up first. Oh, it's 3 at the beginning. Triple.
Okay, everybody got it?
I think it's 6.
All right. So is this ionic or acidic?
Ionic.
All right. Where's the metal?
Oh,
Where's the polyatomic ion? It's got to be either metal bonded with non-metal, or it's got to have a polyatomic ion. Anybody see the one of those in there? Okay.
I feel a polyatomic ion.
OH could be, but it's only polyatomic ion when it's not bonded to a carbon. This is an alcohol. It's not a hydroxide. Okay. So this doesn't break up in water. If it doesn't break up in water, it'll dissolve. Okay, it'll become aqueous when it dissolves, but if it doesn't break up, what is I going to be?
It's going to be all those up to 5.
No.
6. 1. Yeah.
If it doesn't break up, it's just 1. Remember, it's the number of particles a formula breaks into in solution. Well, it only breaks into 1, right? That's it.
So it's like a net ionic equation.
Exactly, like a net ionic equation. Or like a, yeah, well, either one. Okay? All right. Even though it's aqueous, it doesn't break up. Yeah. Only salts. No, it's soluble.
You get it as aqueous or
Aqueous. Because it's not a salt or an acid. Only aqueous salts and acids break up. Anything else that dissolves doesn't break up. Only aqueous acids and salts break up. Aqueous acids and salts break up. Only aqueous acids and salts break up.
only aqueous acid.
Anything else that dissolves in water will have a Van Hoff factor of 1. That makes sense? Okay?
Wait, so you had 2 things in the products that were aqueous. Would that mean that the I equals 2?
Yes. So that's what I have right here.
Okay.
So if there's 2 things over here, that I equals 2. Okay? All right, let's try one more, just for kicks. One more real quick. Okay, ready? Here's a tricky one. It's not really that tricky. Let's just see if you can do it. Ready?
It's a barn burner. You got to scoot that over to your right. There you go.
All right. Find out what I is.
The mark of a crown.
You scoot the paper over, like, so I can read the I thing.
How do you know if it's a solid?
That's so cool.
What? I know if it's a salt? Well, what's this right here?
Sulfate.
And it's a polyatomic ion. Well, you can know from the formula that it's a salt if it contains a polyatomic ion, or if it has a metal bonded with a nonmetal, like these two right here.
So it can break up.
Yep. Well, assuming it's soluble, yes. What?
It's salt, so how do you know it's acid?
How you know it's aqueous?
Acid.
Oh, acid. It has a hydrogen on the front.
Um,
For us in this class, all the acids have hydrogens on the front. We generally don't think of water as being an acid, but it could be. Huh?
Because it's got 8 chips.
Mm-hmm. It gets a lot more complex than that, but we're not going to get too much more complex than that. So anybody listening to this, watching this video that's saying, wait a minute, that's really, really simple, come on. Well, it's because it's that's what we're doing. It's a high school class. We're not trying to get into the really complex stuff right now.
Do you know if anybody else is watching these?
I have no idea. I've got over 120 something videos online now, so who knows who's watching it.
Oh, well.
And by the time somebody sees this, it might be 500. I don't know. Okay. Anybody found the eye yet?
I think it was 5. I think it's 5.
Well, you are right.
Oh, snap, I'm right.
It's 5?
Yes, sir.
5.
Okay, if you're sitting there and listen, hey, class, if you're waiting for somebody to tell you, that ain't helping you much. You got to try. Okay? At some point along the line, you got to get up and go. Make this happen. All right, we got 2 scandiums with 3+ charges on them. And we've got 3 sulfates with 2 negative charges on them. So that's 2 and 3. That's an eye of 5. All right.
I ain't do it like this. I found it like SO4.
Yeah, but polyatomic ions tend to stay together. And that's a polyatomic ion right there. It tends to stay together.
Somehow I got it right, though.
Huh?
Yeah, I see what I switched.
I mean, I can't hear you over this person who's sitting right here in front of me that can't be quiet for some reason. What?
You don't break up sulfate.
No. No, when you dissolve ionic compounds that have polyatomic ions, the polyatomic ions tend to stay together. Okay? All right, let's see. We know what the change in temperature is. Okay? Y'all finished with this down here? Okay, we know what the change in temperature is. We kind of know what I is. Now the constant you just look up. Okay, I'm not going to ask you to figure out a constant. It's something you look up in a chart someplace, okay? And we spent a good bit of time at the beginning of class calculating molality. So you have all the tools you need to do these calculations here. Okay? All the tools you need to do these calculations. Go for it.
I know you were going to do this.
Yeah, little m is molality. Correct. It's classwork. Do it on a separate sheet of paper because you might have to turn it in. Chelsea. Chelsea.
Keep going.